In this last video, we're looking at Mod 2 Lesson 5B, so more solving exponential equations with base change, and these ones are going to have more steps to solve for x. The steps we're going to use are still the same as the previous video, so we're going to isolate the base, take the log, and possibly use base change, and solve for x. In this first set of examples, it looks very similar to what we saw in the previous video. The only thing is once we take the log of each side, we might find that we have to do a little more work to get our variable by itself. So for the first one, same thing as the previous video. We're going to first isolate our base, which is 2. 2 is already by itself. So we're going to take log base 2 of each side. We're going to get x plus 1 equals log of 50 base 2. Okay, so for this one, we have to, we're going to kind of continue to solve for x. I'm going to subtract 1. And keep in mind, I'm evaluating 50 at base 2. So I'm going to make sure that that 1 I just subtracted, I'm not going to make it a 49 or anything like that. I'm going to evaluate that log first and then subtract 1. We end up having to use the base change formula, so if I was to go ahead and write this out, we would get the log of 50 over the log of 2. And then in your calculator, you might actually even put a parenthesis around it. So you would put a parenthesis, log 50, close parenthesis, a division key, log of 2, and then close those parentheses, and then subtract 1. You could also do it a piece at a time, but you know, your display function on your calculator can handle you putting a lot of that in. And then our final answer would be 4.64. If I was to take that value and plug it in, it actually ends up working out. So 4.64 for x, when I evaluate that, you would get a solution. For question number 2, it's very similar. So I'm going to get my base of 4 by itself first. I get 28. I'm going to take the log base 4 of each side. And then I need to get, I'm going to put a little parenthesis around this piece here. And we're going to go ahead then and subtract 3 from each side. And again, I'm not doing 28 minus 3. I'm evaluating that log first. And then going from there. So it's a base 4. Our calculator can't do, can only do base 10 and e, so I have to do the base change formula. And so if we put that all in our calculator, so log of 28 over log of 4, and then subtract 3, we're going to go ahead and get our final answer, which is negative, and if I round it, it'd be negative 0.60. And then for our last one, we're going to do the same thing. I'm going to go ahead and isolate my base first. Take the log base 3 of both sides. And then I'm going to put a parenthesis around that 45. And then I'm going to divide both sides by 4. Now we do have to do the base change formula here. So I would have the log of 45. I'm dividing by the log of 3. And so our calculator could actually handle doing all of that, and then we would divide the whole thing by 4. So our final answer would be 0.88. These last three problems are the same thing, but again, multiple steps, but the same process. So I'm going to isolate my base first. I'm going to divide by 4. So I have 7 to the n minus 1, and then on the other side I'll have 37. I'm going to do the log of base 7 to both sides. And then I have an n minus 1, so I'm going to add 1 to both sides. And then I do have to do the base change formula because I'm doing base 7. So I might rewrite that part here. And so our final answer, if we put all of that into our calculator, we would get 2.86. For question number 5, same thing. I'm going to go ahead and isolate my base. So I'm going to subtract 10. And then again, we're doing base 5. So we're going to do a base of each side. So log base 5 of each side. We have x plus 1, so we're going to subtract 1 from each side. And again, we're going to evaluate that log first, so we can't do 20 minus 1. It's actually log of 20 base 5 minus 1. We do have to do the base change formula because we're doing base 5. So that would be, I'm going to do a big parenthesis here, log of 20 over log of 5 minus 1. And then our final answer would be 0.86. All right, for our last question, we're going to go ahead and do the same thing. So it's kind of repetitive, the same thing over and over. So I'm going to go ahead and add 8 to both sides. And divide by 4. And so for this one, it's base e, so we're going to do the natural log of each side. Okay, and then we're going to go ahead and solve for our variable. In this case, our variable is k. So we're going to add 3 to both sides. And again, we're not making it out of 13. We have to evaluate that. We're just going to do it at the very end. Divide the whole thing by 3. So I might use a parenthesis there. And then we can actually put this entire piece in our calculator, right? So we have the natural log of 10. We don't have to do base change because it's the natural log, plus 3. The whole thing divided by 3, you're going to get 1.77. If you have any questions, you can sign up for T-Bolt time, get help in the center, or ask questions during class.